Okay, can everybody take a seat? We'd like to start the payload. Good morning, everybody. This is the payload working group session, and for some reason I don't see more in the room, which will be a bit of a problem if he won't come back because he has the presentation. Okay, so we'll start with this is the payload session. The chairs are myself and Ali. Ali is not here. He'll join from remote, I'm not sure. What? The blue sheets are going around, and oh, I lost also my note taker, went out. Can I have one note taker? Just there won't be much to take. Any volunteers? Okay, he's back, so this will be okay. I was waiting for you. So we start with the note well. You've seen it because it's already the second day and you saw it on the previous session. The agenda for today is to get the status of the payload working group, and we'll have a presentation on the payload format for the flexible FAQ. Document status, there are no RFC published, but the MELP codec is in Auto 48. It probably will be, maybe it was published today, I'm not sure, but it was already yesterday. They said it's going to be published because it finished all the authors already accepted all the changes on that one. Okay, the RTP how-to is in Auto 48, and Magnus had some correspondence about it.
Yes, so Magnus Western. Yeah, so just last week, I finally got to go through the number of comments I got from the RFC editor on or questions about the spec, and sent my kind of proposal for fixes for certain things. I mean, this document has been 1160 some days since it was approved, so it has aged. There were a couple of things which needed to be addressed, and etc. So there's going to be changes, and I waiting for the updated version, but we might have to circulate something on the mailing list before it gets approved because there's some changes to certain things here. So,
but the on editorial, we won't need to get it back to a formal review. What's the
no? So I think I want to inform the working group of what's being changed here.
Okay.
Because there are changes, so it's that does impact the content to some degree, etc. There's several edits to it in regards to notes about, for example, that the new upcoming RFC format, etc., and a few other things which there are things that has changed. So I want to get it back and see what the changes are really when the RFC editor also has gone through it, but we might have to at least show it to the working group so you have a chance to react to the changes. So.
Okay, so we'll take some time just to review it in the working group for a week and let them see that we need to ask for the review. And we can, I'll definitely review those changes, and maybe Colin is your co-author on that, right?
No, I'm a single author.
Also, maybe I see Colin is there. Maybe Colin will also help us with reviewing that because. I mean,
no, I don't think it's any major things, but there are some changes that we should at least.
Okay.
Yeah,
okay.
And it's been, after all, it's been over 3 years. It's been 3 years basically since.
Yeah, no, I know. It's been there a long time.
Yeah.
This document.
It's only been after 48.
But by the way, this document was very helpful anyhow, even in those stages, to everyone who was writing payload, because we could. As a working group chair, when we got requests about how to do that, I would always point to this document, whatever, because it had the structure of how to write a payload, and that's why it's important. It doesn't matter if it was an RFC or it was a working group document, which was already has the right content in which how to write a specification, a payload.
Yeah.
And thank you for this work, because it's an important thing for this work, this document. Okay, the ancillary payload is in ISG processing, but there were changes in the documents which are not editorial. They did some changes on even in the payload header. Had to do something with alignment, and they changed the structure. So they will submit a new revision, and the document will come back to the working group for another working group plus code, because we need to go through it. We'll see that if we also need afterwards IETF last code. That's something that Ben mentioned on the list when we discussed the issue. Right? So we are waiting for a revision. And by the way, all these changes they were done also based on, they were checking also from implementation that they don't break any implementation, or that will work for them. Those changes will come. It's like a typical payload where we get the payload from that are being used in other standard bodies, and we just need to go through the process and see that the payload, the way that the document is structured and the content makes sense and it works okay. So expect to see a working plus code as soon as we get a new revision for that one. Other DOM status, the VP9 RTP payload. Jonathan mentioned that first of all, it needs editorial work, and the other thing, you said something about support for layer scalable.
So the first thing is there's a bunch of text, basically the explanatory text about sort of getting the background VP9, an overview of its high-level structure and whatnot, which nobody's written yet. And I thought I had a volunteer to help me write that, but he hasn't done either. So we will try to get that. Then the other thing, this is a much more significant technical change, is that I was talking to somebody the other day who expressed some interest in using, well, he mentioned, oh yeah, he wants to do various multicast video, and he's interested in doing VP9, and I thought, oh no, that means I have to support MRMT mode, and I didn't want to support MRMT mode. So the question is, right now we only support SRST for the scalable. Is there interest in MRMT or MRST modes for this? I guess MRST, no MRST, because well, I guess the question would be, I think I had some recollection there were some PERC architectures that wanted MRST, but I'm not sure. But I guess you don't really need that with frame marking. But yeah, so I guess the question is, do we want to delay this, do the work for MRMT? Because I don't want it. So maybe the answer is if in the future somebody wants an MRMT, we can define it as a BIS or an alternate payload format.
So what is the requirement for MRMT?
So basically, you have to explain how you reassemble the original decoding order across multiple streams.
No, I understand, but you talked about.
Basically,
why did it came from?
Well, what he wants to do, he's not even sure he wants to use RTP for what he's doing yet. So it's a very early requirement. Basically, what he wants to do actual multicast streaming, where where you actually want to tune into the multicast group corresponding to the layers you want. So that would require MRMT. That's the original motivation for all of the MRMT modes is multicast.
Yeah, okay.
Yeah.
Which is still also, okay.
Yeah, so my inclination would be to say, let's just do it with single stream mode for now, and then do a BIS or an alternate version of the payload format if somebody wants
if it will be
needed in the future. But,
okay.
Okay, so.
But you should respond and see that it's okay on the mailing list. That it's
okay, yeah.
Because it was.
All right.
Because I assume the guy who wanted it is not here.
No, he's I'm not sure he even realized that was a distinction he needed to worry about. He was just saying he wanted to look at how to, I mean, he's not even sure that RTP is the level where he wants to go for this. It might be some entirely different structure.
Yeah, because in streaming, it's not necessarily RTP.
Exactly, yeah.
It's just, it can be packetized.
So yeah, so I think I said I'm probably inclined to not do that. And then Tim was the one who had volunteered to help me write it, but I guess he's not here now. So I will try to either bug him or my co-authors to see if one of them can write that explanatory text.
Okay, so we're waiting for the editorial work in order to go to last call. Okay, the other documents that we have in the working group is the VC2 high quality, and it is in the working group last call. Probably we don't have enough review, so we'll try to see how to finish this one. Currently, there are no other documents there, so the milestone, we have a milestone that's already expiring now about the flexible FAQ, for a flexible FAQ, and we probably need to update. We'll see how to what is the new milestone. For the VP9, we'll also need to update because we are waiting for revision, and we hope to be able to send the VC2 high quality for publication by May. So these are the only milestones for this working group. Okay. So this is any question, any other issues on the working group? Yeah.
Yeah, Vincent Rocker from INRA. If we have time, I would like to talk a little bit about a proposal for extending fake frame, which is in fact closely related to the presentation we'll have today morning. So using different types of FEC codes in order to protect real-time flows. So if we have 5 minutes for that at the end of the session, then I would be glad to talk a little bit about it. This is joint work with Ali Begin, so he knows this quite well, but I'm not sure if it has already been discussed or introduced in this working group. So
is there a document about it?
Yeah, there is a document. There are 2 documents, but I can say a few words about it if you want.
Okay.
This is really related with the first document that you listed here. And
this one is going to be presented now.
Yes. So after that, I can say a few words about it.
Okay.
Thank you.
More?
Mosinati going to present updates to the FlexFAQ draft on behalf of Varun, Ali, and Gary. Next slide, please. Okay, so we're going to jump. Is that any better? Okay. So in FlexFAQ version 4, there's 3 main changes. The first one is that the SSRC count, remember before we had single SSRC protection, and then I think it was in version 2, we added multiple SSRC protection.
Just to interrupt on the previous topic. From the Jabber room, Thomas Edwards volunteered to review the VC2 HQ draft for working with ESCO. Yeah. Thomas Edwards volunteered to review the VC2 HQ.
Okay, thanks.
Okay, so in an earlier version, we extended the FlexFAQ draft to support protecting multiple source streams. So with a single FAQ stream, you can protect multiple SSRCs. And when we did that, it expanded the payload format quite a bit. And so we've worked to reduce that in this version. So we've actually moved the SSRC count and the list of SSRCs into something that RTP has had for forever. And it reduces the overhead by 32-bit word. And is that a comment?
I'm just trying to figure out. I'm just trying to.
Each of these, there'll be more detail about them. So I'm just giving a list of them. Next change was there was a suggestion to remove the final extension bit, the K bit, extends the mask length. So you can start off with a 16-bit mask, and then you can extend it to a 32-bit mask, then you extend it to a 64-bit mask. And that K bit was extending each one of those masks, and there was a suggestion to remove it from the last final largest mask. And so we saw no reason to resist that. It precludes having larger masks in the future, but I think we're fine with having 110 packets. So we did that. So now the limit is 110 packets. One FlexFec packet can cover up to 110 source packets from that one SSRC. And then what was just discussed in the previous AVT session, there's some complexities around when you use SRTP and FEC together, which one do you do first? And so we added some text that specifies the order to let things like perk work. All right, next slide, please. All right, so the SSRC count and list. This is the old format that was used in version 3. You see there was an SSRC count field in the FEC header, and then a large wasted reserved area, and then you give each SSRC underscore I, give each one of those SSRCs before the rest of the data that goes with that SSRC. So the sequence number, base offset, and the mask, along with the SSRC, those would be repeated as blocks for each SSRC. That was the old format in 03. Next slide, please. So in 04, we moved to actually use the RTP header that we've had all along. And SSRC list and count are naturally things that are already handled by the RTP header by the CSRC count and CSRC list. So we just moved those directly into the RTP header. So basically you can think of these this FEC packet has contributing sources, and here's the SSRCs of those contributing sources, and here's the count of them. So it's clearly not a mixing operation. I guess you could consider, the computation of the FEC code is kind of a mix of them, but logically these are contributing sources. The source packets are contributing sources to this FEC packet. And so we're just using the RTP header as it was intended to be, instead of creating new FEC headers for that.
Jonathan, are you still able to recover the original
Yes.
CSRC list?
Yes. So if you look in the blue up top, that's the RTP header, which actually was never documented in the old version of the spec. So now we show the RTP header. And then the FEC header, which is what's documented all over in the spec. Some people actually confuse that to be the RTP header, and it's not. This is the FEC header. That's the payload, after the RTP payload after the RTP header. And that is where you do the recovery operations. So the source packets, CC count and CSRC count and CSRC list and extensions and padding, and all those are recovered by that. So it's part of the FEC header below the RTP header. So to quickly clarify here, the RTP header in blue up top, the CC there is used. Before it used to just be 0, and so now we're actually using it to indicate how many SSRCs are we protecting. And each one of those SSRCs that you're protecting would go into the CSRC list, just like regular RTP. And now that there's a corner case of whether or not we want to allow CC equals 0, whether or not we want to allow not specifying what SSRC you're protecting. And you'll see in a later slide, there's the retransmission format. We do have a case where we don't put any CSRCs in there. The rest of the FEC header is the same, except for just removing the SSRC count field and the SSRC underscore I field. So you still have the SN base and mask, and those are still repeated in time, CC times for each CSRC in the list.
So does that mean that for a FlexFec CC equals 0 is invalid?
No, I'll get to that. I'll get to that. And actually, we toyed with whether or not some FEC formats don't have the explicit SRC mapping, and so if you can derive it through other means, through external signaling or or through, you know, simple, if it's a simple environment where there's only one stream, then it's kind of unnecessary to signal it. So we haven't documented that yet about whether or not that should be allowed. So if people have opinions on that, but there is one case where in the retransmission format, we do want to allow CC equals 0. All right, next slide. And this is that reason. So in the retransmission format, one of the intents of the retransmission format was to just basically send the entire RTP packet again as payload, including its header. And so in 03 and 04, there's not a change to the retransmission format, but I wanted to highlight here that this is different from the regular FEC format when you have CSRC lists, because here we have no CSRC list. CC equals 0, and the SSRC that you're protecting is in the payload, because you're just basically taking the entire RTP packet that's being retransmitted and sticking it in as payload. So you have a full 12-byte RTP header followed by CSRC lists and extensions and RTP payload from the original packet. So this could have been done either way. We could have required the CC equals 1 here and had it in the CSRC list and omit the original SSRC from the packet, but it seemed like unnecessary manipulation of the original packet when you could just blindly, you know, copy the entire packet. So this seemed better. And actually, to Jonathan's earlier point about, do you want to disallow CC equals 0? Clearly we can't for these retransmit cases. But if we wanted to say that we were not going to allow CC equals 0 for FEC cases, we're only going to allow it for retransmit and not FEC cases, we could actually use that as the indicator of whether or not this is the retransmit case or the FEC case. And then we could even remove the, back up one slide, please. If you see the first 2 bits of the FEC header are the R and F bits. The R bit is the retransmit bit, and the F bit is whether it's a fixed mask, whether the mask is sequence numbers or whether it's lengths, number of columns and number of rows. So we could actually remove that retransmission bit if we wanted to. If we went with the restriction that CC equals 0 means retransmission and CC greater than 0 means it's FEC, and the SSRCs that you're protecting are signaled in the CSRC list.
So Magnus West. Now, seeing how it looks like now, I wonder about why not use different payload types for the retransmission and the FEC, because now you really have 2 different formats and you have a field which is intended to mark this, and that's the PT field. So yeah, now we come back to that question again.
We have kind of come full circle. Yeah. So yeah, the original intent was to use the same format, but clearly there's optimizations to be made if you don't want to have, you know, the overhead of the FEC formats.
Yeah, Jonathan, I mean, I guess that having them be what the same format does is basically say, you know, you can't pick and choose, you must implement both. Yeah. So if that's the thing we want to say, then obviously you could say that even if they're different payload types, that's much harder to enforce rather than just saying, okay, well, this payload type means you support either format on receive.
From a purist view, I would agree with Magnus that, you know, that there's not a really good reason to bind them from a realist point of view, from, you know, real world implementations point of view, and just time time to get this out point of view. It seems practical to have them both and require them both and do it here. But I do agree that logically and I just out of purity, there's not that much justification to have them both in one spec.
So you had a bit. Have you removed a bit for our retransmission, or is it still there? Or?
No, it's still there. So the question is, let me restate Jonathan's original question. That he asked, should we forbid CC equals 0? Forbid having no SSRCs signaled in the FEC header itself. If there's a case where we want for regular FEC packets, not for retransmission packets, but for regular FEC packets, if there's a case where we want to allow someone to specify through some other means what the source SRC is, then that would be a reason to allow CC equals 0. If we don't see that as something we want to support, then we can we can use the CC field itself to indicate whether it's retransmission or whether it's FEC, and eliminate the R bit from the FEC header. So first we need to answer that first question of whether or not we ever want to allow external means of signaling the relationship between the FEC SRC and the source packet SRC.
So my argument for keeping the R bit would be that it also enables you to actually verify that nothing has happened to the CSRC list. Yeah.
Jonathan, yeah, I mean, I'd say one of the things I liked about FlexFEC is that removed the need for all that signaling associating original streams and retransmission streams, which is always a pain to do. And so I'd much rather have the original SSRCs be in here.
So the R bit in this slide is supposed to be 0. Because in the next one you put it as 1. You didn't even put the letter for that, and in this one it's always 0. Right.
When R is 0, it means it's a FEC packet. When R is 1, it's a retransmit packet. So here it shows the symbolic instead of the actual value. Okay, go next slide. And so again, that's the retransmission format. Okay, so the other change, which is I think pretty minor, we just removed the last K bit. So in the biggest mask you can have, that 64-bit field of mask 46 to 109, we just removed that K bit to not allow any further extension. So now you can protect up to 110 packets instead of 109. All right, next slide. Okay, SRTP and FEC order. So 3711 says that when you're using SRTP, that the default order for operations is FEC first and then SRTP afterwards. And I think the motivation was to have integrity protection for the FEC packets. That worked fine up until we had things like PERC, where you have end-to-end encryption, and so middle boxes that may want to look at the FEC or even generate FEC now all of a sudden can't get to it because it's end-to-end encrypted and they don't have the encryption keys for that. And what's notable is that the FEC header itself is considered RTP payload, so the middle box can't even tell what source packets are protected by this FEC packet. So it would have to blindly forward all FEC all the time and would have no idea what that FEC packet is even protecting, which is clearly not optimal. Middle box would not be able to optimally tune FEC rates and characteristics for each participant. It would have to do worst case FEC for the entire conference. So if one person has a bad uplink, everyone's downlink would get penalized. So clearly that's not an optimal situation. And we think that architectures like PERC would benefit from having middle boxes to be able to look at the FEC and generate their own FEC. And so the proposal is that for cases where you have things like SRTP architectures like PERC, we would require that the flex FEC order is FEC after SRTP. So that means middle boxes can receive the FEC packets, understand what's in the FEC header, and generate their own FEC packets differentially towards different receivers. Of course, everything is still end-to-end integrity protected because what you're really recovering is the end-to-end encrypted packet. At that point, you're just basically, a link, almost a link layer correction algorithm, and the higher level layers in this case would be SRTP that would have to come in and validate the packet afterwards and do the end-to-end authentication and decryption.
One thing, yeah. So that means the FEC per the SSRC for each FEC stream for each link or each stream would be different from the middle box, because you couldn't possibly reuse the same FEC stream coming from the source, because then you would be rewriting sequence numbers.
Yes, that's right.
Right. So that's one aspect. The other is, I'll step out. I had another thing.
So this is Magnus. I don't think you can mandate either of them.
Mandate either?
Yeah, no, so both can occur and depends on the scenario where you're using it, and therefore both needs to be allowed. And actually, order of FEC versus SRTP is one of the parameters that's intended to be negotiated by the key management system or for configuring SRTP. So I think you need to have a flexible signaling for this, sure that this place. And I can't remember how it looks, if it's hard to specify like in detail as SRTP or not.
So neither 3711 nor this says it must be this way. It just says the default order is this.
Yes.
So it's up to a spec to come back and say, I'm going to override the default order, which any crypto suite can. But if it doesn't, then we at least want to have the default order be correct for things.
And then it's not. I mean, the case where it's needed, it might be the other way is, I guess, PERC is the argument for having it the other way, but I assume that FleckFX is not unlikely to be used in other contexts also, and there, whereas you have only point-to-point, and where you don't need it. So, and there you should protect the FEC packets also.
Either way would be workable in those cases. It doesn't break anything, but you're right that you get the extra validation of integrity protection of FEC packets.
Yeah, historically in security, if you don't integrity protect things, you get yourself into trouble with all kinds of attacks, and you might also be able to learn things like sending unprotected FlexFEC packets and kind of seeing reaction times and stuff like that. So I'm kind of concerned that this might actually start creating security issues by doing it this way.
Oh, so just to clarify, everything would still be integrity protected and encrypted in any environment, whether it's PERC or non-PERC. You still get integrity protection and encryption of anything that you wanted for the media payload itself. For the FEC packets, you can think of the FEC packets as just being almost like a line code for that link. All you're recovering is whatever was transmitted on that link. You don't recover anything about whether that packet was authenticated or not. You guys still have to do the SRTP authentication of that packet after you do the FEC recovery. So the worst thing you could do would be an attack that forces someone to do extra FEC computation, but you can do that anyway. It's basically a DOS attack using FEC, but you can do a DOS attack anyway with even real media, right? Or with real packets. You can do an authentication attack with a DOS attack, right? I send you a bunch of SRTP packets, and because the order is SRTP and then FEC, you have to try to do SRTP GMAC or something, or HMAC to decrypt it and to figure out if it's authenticated. So that operation can also be, pretty time consuming. Actually, it's more time consuming than an XOR. So that would even be a harder attack vector.
So come back to the question that I had. The second one was, can we actually update 3711 from this one? I don't think so.
No. We're not updating 3711. This is specifying what the default order is for this payload format. 3711 says that other specs can set their own signal or specify their own. And so here we're specifying the default. And I think Magnus is arguing that we should also maybe figure out where it should be signaled in some other crypto suites.
So going back to what Magnus said, I think the whole point of the FlexFEC was that you don't do anything out of band. So I guess we need one more bit, which would say, or you need to say that what order of.
Yeah.
Okay. So the other question was, should we actually go through 3711 or something like that and go and see like what attacks might be possible on this? The second bit was the FEC header, or would that be integrity protected, or only the payload that it carries? So you have the RTP header, then you have the FEC header, and then the payload. So I guess the payload's not protected.
By
Yeah, so-
protected, what you mean authenticated or encrypted?
It'll be encrypted, but it's an XOR on the encrypted packet, right? So, like what you're proposing now is it's an XOR on the encrypted packet, and the tag is
Yeah, so you would recover a packet that would need to be authenticated. You would recover through a FEC operation a packet that then needs to be passed to SRTP for authentication. So the attack vector is DOS by extra FEC protection processing before SRTP authentication.
just going back to the security section of this. It's going to be quite interesting to write this one because we have to go through all the cases to figure out what needs to be like the security property of the FEC stream.
Jonathan Lennox. I mean, certainly for PERC, yeah, I agree that the FEC needs to be done after the end-to-end encryption.
Yep.
After the end-to-end. It doesn't have to be after the hop by hop. And I'm concerned that there's a lot of things, you know, for the non-PERC cases, a lot of things architecturally tend to have the SRTP processing very early and then player flow stuff happening, you know, much, you know, significantly later, like particularly, you know, all the per stream state you keep that it's not the crypto state might be done rather deeper down your pipeline. So forcing this stuff earlier would be a hard architectural change, whereas not doing this, it means that FlexFEC is just a drop-in replacement for AlpFEC or RTX. So I'm concerned, you know, that what this change means for the non-PERC cases. I feel like the repair flows for PERC is sort of a hard problem, but I would rather not make architectural changes for non-PERC if we can avoid it.
Hi, my name is Daryl Piper. I don't understand half the acronyms on this slide, but I heard security percolating, and I'm an applied cryptographer, so I'm curious, do you guys care about replay attacks against this protocol?
Yes, yes, absolutely.
Okay.
So everything would still, all SRTP processing would still have to happen in either order. You still have to do the full replay list, authentication.
So underneath all of this, what are you using to do this, the anti-replay detection and stuff?
This doesn't specify what SRTP to use, so you could use any SRTP that, you know, if you want to use classic SRTP.
Linked against any library, or
you could use classic SRTP, you know, 3711 with, you know, AES, or you could use the newer AES with HMAC. You could use the newer GCM suite that has built-in.
where are those things documented? Their encoding formats?
They're separate RFCs.
In here, in this group?
AVT,
Ancestral to this group. Ancestral to this group, I'd say.
group of people, but not working group.
But there are RFCs?
AVT core, yes, AVT core RFCs.
So yeah, I think the payload format should actually, you could discuss this, but it shouldn't specify it because it's actually not on FlexFEC's order and default. I think needs to be that you're not touching it. It's up to say SRTP and the configuration of SRTP. And the one of the issues that this applies to PERC is that DTLS SRTP defaults and has no currently specified signal for reversing the order of the SRTP and FECing.
That's one of the motivations for wanting to get the default order right.
No, but
people don't really signal.
Yeah,
the,
but I mean,
the
default order is applied on SRTP level. It's not applied on payload type level because you can't really do this operation on a payload type specific level. You need to do it because it affects how you modularize the things between the RTP stack, SRTP module, and then the FEC. It kind of applies to the session level and not on the individual streams. So you have to be careful here. And that's why I think it's not this payload format's role to actually try to affect this. And then obviously PERC needs to write specs and possibly signaling to amend this.
Yeah. We could leave it out of this document completely, but I think we do need to document it somewhere. Someone needs to specify how should FlexFEC operate.
So just a second. So are you going to discuss it in PERC also? Because definitely, that was when I was listening to him, I said this is a PERC issue because it requires that if you're saying it needs to be in the signaling, it's definitely something that is need to be done in PERC because the signaling is also an issue.
So Boris has a draft on RTX, which is similar to the same kinds of considerations as FEC. I don't think you actually talk about FEC in it, but it touches on the same problems, and I think whatever solution is derived from that could probably also be applied to FEC.
And what would be the conclusion? Will we have something about the issue of when to do the SRTP? Is it before or after the fact in the payload, or we leave it to 3711 and to PERC? I mean, that's a question because it's like Magnus said, it's not. If you put it in the payload, I mean, you can do it, but it's not the place to do it.
Yeah, I mean, Jonathan, I mean, I think to Magnus's point, I think it's going to be, I mean, if you want to try to use FlexFEC but fall back to older stuff, you're going to offer FlexFEC, AltFEC and RTX, and you don't want to say that, okay, I have to do my FEC processing in a different place than the code depending on which payload format I get. That would be chaos.
But on the flip side, you're saying that which FEC processing do you do would depend on what kind of SRTP you're doing.
Yeah, well, I mean, PERC obviously behaves a lot differently than a regular FEC. You're doing double, right? So, I mean, I'd say that, when you're negotiating that you're doing double, that means that you need to do your repair flows a bit differently. It's sort of inherently, because obviously you have to do it, again, after the end-to-end. Whether you do it before or after, hop by hop, that's something PERC's going to need to decide.
So Colin's not here, so we could just say put it in double and we'll be done.
Yeah.
We'll put it in double. So I think the conclusion is that we'll have the discussion in PERC, and maybe that'll help clarify whether PERC is going to specify something for this, and if they do, then maybe we can remove it from FlexFEC and let PERC specify it.
And we'll need to decide whether or what we specify in this document in terms of that, because currently if we don't specify anything, I would assume it's like 3711, which means you do it before the SRTP.
Yep. So if we say nothing, then it would be the same default as all the.
So we'll have to wait to discuss it in PERC. Okay. Yeah. So that's in the, and then we'll come back and give the feedback to the.
So anybody interested, come tomorrow to PERC and discuss it.
Okay. More did you get it?
Daryl Piper again. I was just wondering if you guys had, I assume this is for protected video content delivery. But
not necessarily like a professional, not necessarily high value content. Just it could be, privacy,
just for
video
privacy
conferencing,
reasons,
privacy.
right? Fine.
Yeah.
I'm just kind of wondering if you've considered and looked at and thought about using all that crypto and security we designed in IPsec and multicast and the old stuff.
So the general, what we are doing in RTP, we're specifying how there's SRTP to encrypt RTP, but we have a document that says you can use other mechanism. If you have like IPsec or whatever, there's a document that discusses this and says what other options are to secure the
yeah, I guess I'm just advocating that be a route people can go to use IPsec. Okay, thank you.
Okay, next slide, please. Anything else on so the result was we're going to discuss it in FEC, and we hopefully will be able to remove anything related to SRTP out of this spec and let it be documented somewhere else. Next slide. So that's it. The only other open issue is I think that the protection and recovery procedures need to be clarified a little bit. So people could take a read through it and see what's clear and what's not clear to them. That would be helpful. Otherwise, I think we're done and ready for.
Okay, just to summarize where it stands. So there were, in your here you have three changes that you wanted. So on the first two, we didn't have any discussion; that they were accepted. Mm-hmm. The third one, we have to wait to decision what after PERC, which means that anyhow, in order to go to working class core, we still need to finalize the third issue there.
Yep.
Okay.
Yep. Agreed.
Okay. Thank you. Any other? So this is the last presentation, formal presentation. Any other issues someone want to discuss today? Okay, so thank you. We finished about 15 minutes. Yeah.
Okay. So Vincent again. Just a few minutes, I will be brief. I wanted to introduce very briefly what we're doing at FakeFrame. So I don't know how many of you are aware of FakeFrame. This is a protocol that was specified by the FakeFrame working group, but not in this area, in the transport area, which is probably the reason why we are not, there were not so many exchanges between us. So it was done in RFC 6363, well, maybe in 2011, I don't remember exactly, but around these days. Since then, the working group has been closed. So why I'm here today is that we are extending this protocol, FakeFrame protocol, towards new types of FEC schemes, FEC codes, namely convolutional codes. So there are two interesting things, I think, in this work, which is, by the way, joint work with Ali again. First of all, a different architecture, and if I can discuss with some of you what are the differences, the benefits of doing FEC within RTP or below RTP, because FakeFrame is somewhat a shim layer that fits between RTP and UDP, then I would be very happy. That's the first point. And the second point is those FEC schemes that we call convolutional schemes, FEC codes, they work in a totally different way from what we had here with XOR codes or Raptor codes or with Solomon codes, LDPC codes, all of them. Those are not block codes, they are convolutional codes, which means that there is a sliding encoding window that will slide over the source flow. And whenever you need to produce a repair packet, well, you just have to create a linear combination of the source packets that are within this encoding window, and that's it. You send it. So it's totally different, and we carried out extensive performance simulations, and there is a key benefit in using those codes in terms of improved robustness and reduced end-to-end latency in terms of FEC coding and decoding. So if you are interested, first of all, there will be a presentation. I will do that presentation in next TSV meeting, which will take place on Thursday afternoon. I think this is the first afternoon session, TSV working group. And otherwise, I will be happy also to discuss with you, to show you more details on performance simulation or all this stuff.
Okay, so if people are interested in that, they can go to this session. On the other hand, for looking at other further corrected scheme, we decided that okay, you can do it afterwards in a documents that explain how to do it with other scheme. That's what we discussed, because when we discussed which way to go here, that was the conclusion that the working group had at the time. Okay.
Hey, Daryl again. Yeah, I just glanced through 7201. Looks reasonable. Thanks.
Okay, you're welcome. Okay, thank you all, and thanks for the good work, and we'll hope to see you again in next IETF meeting in Prague. Bye. Blue sheets, where are the blue sheets? If anybody didn't sign, please do it.
Well, I think the answer is because they want to double as a drop rotation, so they don't want to have to do some encryption and then processing, then encryption, which makes some sense, but then they need to get the points.
Where's the other one?
Right. Yeah. Yeah, I mean, you double encryption. And you probably want to do this, I don't know, some metadata, I don't know, I need to talk to you're talking a little bit, probably if you talk to Colin, and he'll tell you it's already in system products.
Exactly for correlated. Yeah, it's fine the same as